Welcome, everyone, to Foundations of Functional Programming in Scala. My name is Julien Truffaut, and I will be your instructor for this course. So let me introduce myself. I'm a backend engineer, probably like you, with more than 10 years of experience, mostly in Scala. I'm also the author of the popular open source library Monocle, which helps developers easily access and transform deeply nested data structures. Finally, I love teaching. I've been running meetups, study groups, and in-house training sessions on functional programming for a while now, which has helped me gain a real understanding of the pain points that people have, and I've designed this course to target them. So with this Foundations course, I have two main objectives. First, I want to show you the practical aspect of functional programming. FP is a vast field of study, and we can easily get caught up in its complexity and lose sight of our original goal. At times, it feels like we need several lifetimes, or at least a PhD in mathematics to grasp it. But a good analogy is like driving a car. You don't need to understand every moving parts of a vehicle to drive it from A to B. And this is the same with FP. There is a simple, pragmatic side to it that makes us more productive and lets us write code that is both more robust and easier to maintain. And so by the end of the course, I hope to convince you why FP matters to you as a developer, but also why it matters to the organization you work for. The second objective of this course is to improve your mastery of the Scala programming language. As we learn FP techniques, we're going to take a deep dive into how they are implemented in Scala and how to use a compiler and an IDE as efficiently as possible. I will share with you all the essential tips and tricks I've acquired through almost a decade of using Scala professionally. In addition, a major new version of Scala, Scala 3, is just around the corner. So I'll also take the opportunity to bring you up to date and introduce you to some of the key changes that are coming. So what are the prerequisites for this course? Almost none, actually. I only expect you to have a basic understanding of the Scala syntax. That's it. Of course, the more experience you have, the easier it will be to follow some of the more advanced lectures and to complete the exercises. However, I've carefully designed this Foundations course to ensure you never get stuck, whatever your current level may be. So how will it work? Each exercise has answers and tests that go with them. So if at any point you're unsure how to complete an exercise, you can always check the solution. But answers alone are not enough. There is often more than one way to solve a problem, and your approach may well be as good as mine. I believe the real opportunity to learn isn't in the solution, but rather all the steps taken to get there. So I've included unique walkthrough videos for each exercise, where we discuss various approaches to the problem and write tests for them. This way, I can offer you an experience as close as possible to pair programming, which in my view is the best way to learn. Even after all that, you may still have questions. So I've created a private Slack community where you can freely discuss functional Scala with me and all the other participants of the course. So, what exactly are we going to cover? I've divided the course into 6 chapters. In the first 2, we look at the different ways to define functions in Scala and how to test them using property-based testing. We'll also learn how to use generic data structures and functions to improve the documentation of our program and reduce the number of tests we have to write. In the third chapter, we'll encounter a very popular application of functional programming, when we process a large volume of data in parallel. And during that section, we'll build a parallel collection from scratch, and we'll use it to analyze a real dataset of global temperature. It should be lots of fun to learn powerful FP concepts while we optimize and benchmark this application. In Chapter 4, we'll answer the following burning questions. What is functional programming, and how can it help us write better programs? What are its limitations, and why isn't it more popular? Among other things, FP offers excellent refactoring capabilities, which are crucial to maintaining large code bases. However, we need to introduce some restrictions to the way we code in order to extract the full benefits. Such limitations can sometimes feel too strong, and it may seem impossible to write a real-world application with them. So in Chapter 5, we'll learn how to work with those limitations and how to interact with external systems. We'll implement a basic version of the I/O data type and learn how to test the programs that use it. Finally, in Chapter 6, we cover how to handle failures and discuss various domain modeling techniques. So if you want to learn the practical side of functional programming and gain skills that are in high demand in the job market, please join me for this Functional Foundations course.